In this video we are going to talk about fractions with the denominator with prime quadratic factors. So this is type 3. Now let's see an example. Okay, in this example we have x and x squared plus 3 as the factors, and x squared plus 3 is prime. Well, how do we know that? There are two ways to show it. First, you can write an equation saying x squared plus 3 is 0. Then how would you solve that? You would just take 3 to the other side, saying x squared is minus 3. So this means there is no solution, because no real number can satisfy this equation. No real number squared is negative, right? So there is no solution. This means you cannot factorize this expression. So x squared plus 3 is prime. Also, you can check the discriminant, which was b squared minus 4ac, saying that for x squared plus 3, well, a is 1, b is 0, c is 3. Why? Because in general we write the quadratics to be a squared, a times x squared plus b times x plus c. So, see, the coefficients of x squared should match. Coefficients b here should be 0 because there is no expression here with the x term, and c is 3 here. So if you substitute these values into the discriminant, then you will find that it is minus 12 less than 0, meaning no real roots. So there is no solution, hence no factor. So this expression x squared plus 3 is prime. Hence, as a partial fraction decomposition, we are going to write, well, we have x here, so we will write a over x, plus we will have bx plus c as a numerator, divided by x squared plus 3, because the expression here is in second degree. My prime factor is a second degree expression, so at the top I should have at least a first degree expression. Plus, well, since this is also a repeating factor, you see there's 2 as exponent here, I have to go like dx plus e over, remember I have to write this squared expression as well. So what I should do is, now I'm going to write the factors so that I will equate the denominators. Now for the first one I have to multiply this by x squared plus 3 squared. For this second one I have to multiply it by x and x squared plus 3. And the third one I have to multiply only by x, so that the denominator will be x times x squared plus 3 squared. Now let's start equating the denominators. Now before, I have to find what I should multiply with the numbers at the top. So this is nothing but x squared plus 3 times x squared plus 3, which will give me x to the 4 plus 6x squared plus 9 when I expand this expression. So I'm going to use this to multiply with a. So it will be like a times x to the power 4 plus 6 times x squared plus 9, and of course plus. Now for b, I have to write x cubed plus 3x here when I expand the brackets, and then I should multiply bx plus c with x cubed plus 3x. So it will be like bx plus c times x cubed plus 3x. And for the x plus e, I will just multiply it by x, so it will be dx squared plus ex. So let's expand the brackets. We will have the following when we expand a, and for expansion of the middle term it will be like bx times x cubed. You will have bx to the power 4 plus bx times 3x, it will be 3bx squared plus, you will multiply c by x cubed and then c by 3x, so it will be like cx cubed plus 3cx, and then I write the rest, dx squared plus ex divided by our denominator. Now we have to take into common term parentheses, so let's erase the parts at the top. So let's see, now we have x to the power 4 here, x to the power 4 here, and nothing else, so it will be x to the power 4 brackets a plus b. Now for x cubed we have cx cubed and nothing else, so it will be cx cubed, and then we have 6ax squared, 3bx squared, and dx squared. It will be like x squared parentheses 6a plus 3b plus d, plus for x parentheses it will be like 3c plus e, 3c plus e, and we are only left with 9a as a number divided by the denominator. Now we can write our own system of equations from here. A plus b is 3, c is 0 because there is no x cubed here, and 6a plus 3b plus d is 8, and it is actually not 8, 4, and 3c plus e is 8, and for a number 9a is 18. So let's start solving. Now first I can say a is 2, and I substitute here. I have 2 plus b equals 3, so b will be 1. Let's take them into boxes, and I know that c is 0. Now I will substitute these two values to find d in this equation. So it will be 6 times a, which is 2, plus 3 times b, which is 1, plus d should be 4. So this is 12 plus 3 plus d, which is 4. So it will be 15 here. So 15 plus d equals 4, and d is from here minus 11. So let's substitute the values. So it will be like let's remember, a over x plus bx plus c over x squared plus 3 plus dx plus e over x squared plus 3 squared. So this reminded me that we haven't yet calculated the value of e. So for c is 0, e will be 8. So let's now substitute the values finally. So it will be like a is 2, so I'll write 2 here. Then bx plus c. B is 1, c is 0, so it will be only x at the top. I will write meaning, yes, sorry, I will write x only. And for dx plus e, I know that d is minus 11, e is 8, so it will be like minus 11x plus 8. So this is my partial fraction decomposition with the denominator with prime quadratic factors. Now is your turn. Write the partial fraction decomposition and show me.